This is a Carboline production.
Previously on the Red Bucket, we began our exploration into all things concrete with our friend and AMP instructor, Paul Kennington. This month, we continue our conversation with Paul, discussing moisture effects, inspection, testing standards, and when to coat the concrete. All of that and more coming up next on the Red Bucket. If you missed last month's episode, Coating Concrete Part 1, be sure to listen to it before continuing. And now we'll dive back into the conversation. There's a great document. I call it the Bible for coating concrete. It is the NACE 6 SSPC 13. This document carries not only what you need to do before you coat the concrete, it gives you how to inspect it afterwards, and pretty much references all the relevant ASTM standards that will help you. And it contains, I would say, the 80-20 rule. 80% of everything. There are some things outside of there, and probably I'd even give it 90 or 95%. Yeah. But there are some other methods, and we'll talk about that. But
it's a good rule.
Yeah,
not the exception, but the rule.
Correct. It's got almost everything you need to know. And I think one of the things that it starts with is the inspection of concrete before you do anything. Let's talk a little bit about moisture in concrete and why moisture can be a problem.
Well, especially if you have coatings that are very sensitive to moisture.
Sure.
Wrong coating system.
Correct. Correct. Yeah.
And not all epoxies probably are the most tolerant, but you also have other things that you can do. And some of them, the simplest way I always tell somebody is do the plastic sheet method. You use a little visqueen 18 by 18 square, you put it at every 500 square feet, and it'll tell you. But that's moisture vapor and plastic sheet method and relative humidity probes typically are only very valuable when you get into an enclosed building where we have HVAC, heating, ventilation, and air conditioning that's going to be work because Mother Nature likes to hit an equilibrium.
Yes.
Yep. Yes. And so that's where we run into a problem. Now, when you get outside, when it can be diffused in all directions, that's where it gets much tougher.
Yeah, so let's talk about that MVT. So that's basically a problem when you have slab on grade.
Yep.
Mm-hmm. And you have moisture and usually cold in the ground. Yeah. And the warmer air above that slab.
There's your equalization.
Yep. It wants to pull the water through the concrete up into that drier air. So you have the damper soil, drier air.
But that's how we have rain, right?
Right.
Same process. Yeah. So if you think of it as rain, how does that happen? Same thing can happen with our concrete substrate. Mm-hmm. And so we have ways that civil engineers can design. Here's the problem that we have with concrete. Designing is only part of the issue. It's the implementation of placing it the way that it should be. Mm-hmm. So many times what we'll do is we'll put a moisture barrier down.
Sure.
That will minimize or mitigate moisture from transmitting through your earth. And it's only, anywhere from 2 to 6 mils sheet good. Mm-hmm. But placing it is where the problem comes in. It gets holes punched in it from the chairs or from people not paying attention or something's in their way. They ignore it. So we have that problem. But just as moisture will rise to make rain, so does it come through the concrete. And that's where we have problems. And then it brings all those uglies, calcium salts, whatever is left in the concrete, because concrete's not a fully reacted material. In fact, some civil engineers will state that it still reacts as much as 25, 30 years later.
Yeah.
Wow.
And so with that in mind, we have those physical properties going on, and it's difficult for a coating. Typically, if it's 3,000 PSI Portland cement, your surface tensile strength is about a 10% value of 300. And so that's how we rate coatings if it's acceptable for concrete, because if you put an epoxy coating on and it has far greater properties and you do a pull test, the concrete will fail and wherever its weakest plane is. So with that in mind, that's why most common Portland cement design is 3,000 PSI, because it'll take, now when you get on highways or superstructures, it all changes, but still, but what we see in our industry is that it's generally type 1, 3,000 PSI Portland cement.
When people ask me, what kind of adhesion values do you want to see? And my answer every time is, honestly, I don't care what the number is, as long as it's concrete failure. The concrete should fail because all of the coatings are going to exceed 300 or 400 pull-off adhesion. So typically I'm like, no, I just want to see concrete on the back of the paint. That when you pull it, that's what should fail.
And so that NACE standard, it gives us, the plastic sheet test is the first moisture test that it gives us. And I, like you said, I always recommended that people do it first. It gives you an idea, a pass-fail criteria of whether or not you have moisture.
Yeah, it's a qualitative test.
Yeah, no indication what the level of moisture coming through is. Just, do I have moisture?
Yep.
So that's really where the next one comes in, the F1-1869, the calcium chloride test. Now we can get a rate. Let's talk a little bit about that test.
Yeah, the National Tile and Rubber Association says that we should not exceed 3 pounds per 1,000 square feet in a 72-hour period. And that's, if you're not an engineer or you're not into math, you say, what does that mean? Well, basically, it's a quantifiable figure that once you measure the calcium chloride disc, you measure it, seal it, and then after so many hours, you take it off, reweigh it, and there's a mathematical calculation that they use. And what they have found is that if it doesn't exceed 3 pounds per 1,000 square feet in that period of time, chances are your coating that you put on it will not fail.
Yep.
But it doesn't say that if you don't have impurities in your concrete, because every time you have a chemical reaction, you give off a gas.
Yep.
And so that's where sometimes we see blisters and bubbles in coatings. Because we have to remember most of the things that we paint concrete with are plastics.
Sure.
Yep.
So one thing I think that I always tell people about the calcium chloride test is everybody's bought a pair of shoes. And in that shoe comes a little packet. That little packet is a moisture it absorbs moisture. It's not,
you had the right word, moisture scavenger.
Scavenger, yeah. Let's see that painter getting into chemistry, right?
Yeah, that's right.
And so when it absorbs all the moisture, that's the same way the calcium chloride does. You said you measure, well, you weigh.
Yeah, and we call that adsorbent rather than absorbent. Yeah.
Right. And that calculation that sounds weird is really just how we talk about that rate. You talk about with cars, miles per hour, right? And if you didn't understand that, or kilometers per hour, that would be weird. But the 3 pounds per 24 hours per 1,000 square feet really is because that's how long you run the test. That's how frequently you place the test itself. And then that 3 pounds is your rate. And so, it sounds very convoluted, but the standard is very clear how you get that calculation.
And the calculation, although it is math, it's pretty straightforward.
Yes.
When you buy any of these kits, it is literally plug in the first number, plug in the second number, subtract, and multiply here.
Yeah.
It is literally step by step. And honestly, it is the same thing. We put new hardwood floors in through our house. You go to the hardwood floor suppliers, they sell this kit.
Yep.
Yes.
It is all, anybody who works over a concrete substrate, puts anything over it.
Yep.
Slab on grade.
Well, I mean, anything over concrete, because
it could be elevated.
It can be because if you're elevated over an area that has a high moisture content,
true.
that concrete's going to absorb it.
Oh, I've seen it over steel.
And so the third test is the F2170, the in situ humidity probes. Let's talk a little bit about the difference there, because we have pass or fail with the plastic sheet. We now have a moisture vapor transmission rate with calcium chloride. Now we're talking about humidity.
Right. And so there's where you get into a misnomer, because if there was never a visqueen, you could do it today during a dry season and you could get very good results. And then during a wet season, you can get very poor results. And I've seen that happen to where it gets into he said, she said type thing.
Well, I think that's an important point to bring up. All of these are a snapshot in time.
Yes, they are.
You brought up conditioned space where we really have a problem. Well, when you are doing these tests, let's say you're doing new construction, if the final area is going to be conditioned, you need to run these tests in that exact scenario.
Right.
You can't run the test when the building's all open and expect it to be the same when the building's closed.
Because you have the moisture travels with least resistance, right?
Right.
Everything.
Right.
That's part of life. And so if you're not confined at the time that you do these tests, the tests only capture that snapshot of that particular time conditions.
Yep.
And if you're in the summer, let's say you're out in the desert, it may not show you any problems, but you enclose this, and many times buildings add humidity.
Right.
Mm-hmm. And then you got the differential of the soil versus the climate inside of the building. Mm-hmm. And it could be a 20-degree difference or more. Yep. And so when you try to reach equilibrium, you have a problem. And so there are companies out there that specialize in mitigating moisture in concrete.
Sure.
And with that in mind, you have to understand that it's very expensive to do that.
I think one of the things that's important for our listeners to know is that just because you maybe reach a high level, so with the calcium chloride test, it's no more than 3 pounds per 24 hours per 1,000 square feet. For the relative humidity test, which just tests the humidity within concrete, we don't want it to be any more than 80%. But the asterisk there is that's for standard coatings. Yes. There are coatings that are designed for these things. And like you said, there are some epoxies out there that are specifically designed for this. But really, I mean, what I love is urethane cements. It's you're putting a cement on a cement. You're in it, and historically, urethane cements are unaffected by moisture vapor transmission, and so, and I think it has to do probably with the porosity of the urethane cement itself. Yes. And so, when it gives a place for that moisture to go, the epoxies are rigid. They're tightly cross-linked. They don't.
They're too dense.
They're too dense. Right. The urethane cements, I mean, I think I've said it on this show before, but I've definitely said it in the concrete presentations that I give frequently, is that a different guy that I knew who had been in the resinous flooring world for years used to always say, if you want to have problems, use epoxy. If you want it to go smooth, use urethane cement. and that's not an indictment on epoxy, because epoxy is still the most widely used coating material for concrete, and it is great. But when you get into these high moisture vapor situations, you really need to be using specialty epoxies if you're going to be using epoxies. I think that does a really good job of summarizing up water and MVT and the problems that you're going to have there. So when we're inspecting concrete, there's also more to it than that too. Sometimes you can visually see when you walk in, like, not new concrete at this point, but maybe we're coating aged concrete. You can walk in and visually see some contaminants and things like that.
Well, we said earlier that typically concrete will have around 12 to 13 pH freshly poured. Well, if you come across the surface and the pH is below 9, I'd have a concern. If you come across areas where the pH has above a 12, I'd get really concerned, because that means they've probably been dumping chemicals that are high alkaline nature. The acid side of it goes after the cement portion.
Yep.
Okay. And they'll neutralize each other. But the other problem is with high alkalins, and we say, concrete's high in alkalinity anyway. Right. But here's the problem that we have is that the sodium hydroxide and those hydroxyl groups and any other type of high pH materials will go after inorganic matter such as rock and sand. And so if you take the rock and sand out, then all you have is a porous structure like a sponge. Mm-hmm. And so I have seen many times where they say, well, the pH is 13, I said, did you test? Have you done a petrographic study? And so sometimes you may have, if it's a caustic deck, for example, where they're going to expose it to high pH surfaces, look at it. And so you want to see how deep you have to go. And you may have to do a small core sample to see how deep you have to go till you reach the physical properties again. Because it's typically not all at once that concrete fails. It fails from generally the exposure area down.
Yep.
And sometimes you walk into a place and you just see that. Like before you even begin to do anything, you can see the damage to the concrete. You can see, heck, oils, greases, things like that. They're very visible to see, and they have to be dealt with. And,
Right.
And traditionally, oil contaminated concrete, if you're going to coat that, that meant that you're removing concrete down to non-contaminated concrete. And that's still a method that is used today. There are some products on the market though that are advertised as microbiome, that will eat the oil and things like that. And those are used with some success. But really, when you get into these things, because concrete being a sponge, there's nothing you're going to do to get that oil out. It's usually 2, 3. It sucks in inches down.
Yeah. So what you try to do is just get your surface clean, and then maybe do a pull test to make sure you're going to exceed the bond strength. And because if you're looking to remove that stain, chances are you're going to be removing concrete, and the owner's not going to be happy with you.
I worked on a project where that was exactly what it was, and the spec read that all traces had to be removed. And they did the analysis, and it came back, and partially fortunately, it was a ridiculous thickness slab of a old building. It was like 18 or 24 inches was this slab. But they came back and they said, we need to remove 8 inches of concrete to get rid of all of this. Is that truly what you need? And we had to look at it and say, let's do an adhesion test. Get it as clean as we can. Go through all of our cleaning processes, let it dry out again, and let's do an adhesion test. We'll do a spot. Can we live with that analysis? Or are you removing 8 inches, a third of your concrete slab, and repouring? And it turns out adhesion was fine with what we had to do, and they said, yep, we can live with that.
Yeah, there's where I would say make a tank inside of a tank. Do what you have to do, mechanically attach something, and then put your chemical resistant barrier on top.
Yep.
And I think after inspection and you look and you're figuring out, okay, now we've gotten the concrete, we know we can coat it. Now we have to do the surface prep. And steel, it's kind of easy. Here's all these cleanliness methods and standards, and we're going to give you a profile and a measured profile. And if you've ever blasted concrete, it's not even. There's not an even profile that you really can measure. And so one of the things we really look to, and this is a great contribution to the industry from the International Concrete Repair Institute, and that's the CSP standards. Let's talk about how great those are for a minute.
Well, they're quantifiable. That's what I like. You can actually take from CSP 1 all the way, is it the 7 or 9?
9.
Okay. Yep. And so typically, and it depends on what kind of conditions you're going to go into, whether if you specify 3 to 5, 5 to 7, or 7 to 9. If you're going to be in constant immersion and it's going to be thermal cycling, you'll probably want 7 to 9
deeper profile. And I think a good way to talk about that is when you get these standards, they're rubber forms. It's a visual standard. It's a visual standard that isn't just a picture. Now, they do have pictorial standards that kind of show you. And then those are easy to find and readily available and don't cost any money. However, the thing that every inspector should have if they're doing concrete jobs is, especially if it's specified this way, and specifiers should definitely be using this method to guarantee that you get the profile needed. Because as we know for steel, and we've talked about like profile and coating thickness and everything else, is so important. We're increasing the surface area so that we can get better adhesion, and we're going to need more surface area depending on, like you said, the harshness of the environment. And so these standards are 3D. There's no question whether or not the surface profile that was desired, whether it was achieved or not with these standards.
Well, and what does profile mean? Well, we hope to remove the latents. That's one of the things it means. Yeah. And we hope that it removes any impurities left on the surface, which could be part of the latents. But we also hope it gives us a roughened surface so that we can have good surface area to bond to. But with all that in mind, if the concrete doesn't meet the physical properties, we know that the coefficient of thermal expansion of concrete versus coatings is totally different.
Yep.
And so what we hope to, by doing proper surface prep, just like we do with epoxy coatings on steel. We do the same thing with concrete, is that if there's thermal stresses, it's passed through the film rather than at the bond interface.
Right.
And that's the most crucial thing, is the bond interface. And we know that the concrete's going to be weaker than coatings. That's just a known fact. You can look at physical properties. So with that in mind, if the contractor can do the best that he can do under the circumstances that he's placed in, then chances are you may have a long-term success.
And we've talked a lot about concrete. We've had a good conversation here today, and I think there's one more tip I want to include before we wrap things up is, when should we be coating concrete? Like, what time during the day?
Oh, you mean, as I heard a concrete expert say one time, he said, even though concrete is inorganic, it is a livable, breathable thing. We do know, we've discussed it earlier, it is a sponge.
Yep.
And during cooling situations, we take in air and moisture, okay, into the concrete. And during warming situations, we expel it. And that's outgassing. That's one of the problems that really can be exacerbating when you're trying to coat concrete. When do we do it? Well, there's several methods that people go about. One is to get a fast set primer and coat it when the concrete temperature becomes stable or starts to decline. And then sometimes there's a chemical reaction going on in the concrete that none of us know about, and I've seen it happen.
Yep.
And it could be from below the concrete. But we should plan on always priming at a minimum when the concrete temperature is stable or descending. And so that may only require you to work one night or 2 nights if it's a secondary containment area to get it primed. Because the other thing is you got to keep in mind that no one covers the surface 100%. Right. The effective bond area probably at best will be 92 to 94%, even with a very efficient crew. And so you still have the potential for outgassing. And outgassing is generally when the concrete is warming. There's a thing called off-gassing, is when there's something going on below the surface that may be due to the fact that the concrete has impurities in it, like AAR or ASR, okay, that the moisture is being consumed and it keeps it reacting. So there's many things that we can't give an empirical answer as much as we'd like to.
Right.
And so many times it requires test patches to see what will happen. But I can tell you right now, outgassing is the enemy of coatings.
And Paul touched on it a little bit as we talk about that difference in temperature and what draws the moisture or the gases through the concrete. Even if you're coating at the right time of day and the temperatures are cooling, if you're applying a coating that has a high exothermic property, it could start that process again.
Right.
So it's not a guarantee that just because I painted at midnight, all things are great. You could still have problems.
That's why you need a thin film penetrating impossible primer.
Yes.
Because, if you bridge, which you're going to do, because most of our epoxies today are very high solids, and if you bridge and it starts going through an exothermic reaction, it only takes a 2 to 3 degree differential in temperature to start outgassing.
Sure.
Yeah.
In concrete. That's the thing people say, well, it didn't go up much, it only went up 1 degree.
That's 50% of what you needed.
Yeah. So.
As you guys can tell, Paul Kennington, not Paula Jamis. Well, Paula Jamis knows what he's talking about too, but Paul Kennington is definitely well versed in this. If you have any questions for him, again, you could reach out to Paula Jamis at technicalservice@carboline.com. But now we're going to do what we do with all of our guests, and we're going to get into what we call our 4 question segment. So, Paul, what's your favorite movie or TV show?
I would say The Green Mile was my favorite movie.
Oh, boy, that's a
good one.
Yeah.
Yeah, I mean,
little Tom Hanks.
Yeah.
What's your favorite hobby? When you have free time on your hands, I know your schedule and that doesn't happen very often, but what do you like to do in your free time?
I typically, lately, I've been really into home remodeling. I enjoy that when you start from nothing and you from the wall up, plumbing and all, electrical.
Yep.
Yeah. I've enjoyed that as a part of my retirement package. And it's enhancing my home as far as value, but it's also enhancing, it gives me something to do to stay out of trouble. What's the old saying? Idle hands are the devil's workshop.
That's right. That's right. You spent a lifetime working with concrete, and now you get to play with some other materials, huh?
Yeah. And some concrete. Yeah.
You're a wrestler or a baseball player. You're coming out to the ring. You're coming up to home plate. What's your walk-up song?
Lord bless me, I need your help.
That sounds like an overly confident answer. No, I'm just kidding.
No, because you never know what's going to be thrown at you, literally.
Yeah, literally. All right, we got one more, Paul.
Yeah, last one. You're a Houston native, so I can guess where this is going to go.
Yeah.
But if you were watching a sports game, a team, what do you follow? What do you like to watch?
The Astros. I mean, that's a natural. And, and of course the Texans. I mean, the only advantage we have over the St. Louis group is that we still have a
one.
team.
Yeah, I don't know if I'd rather not have a team than have the Texans.
Well, there's always hope.
Yeah. Thank you, Paul, so much for coming on the show.
Thank you for inviting me.
I appreciate it as always. As you guys can tell, I love this man. He has taught me so much about coatings, and I'm glad that he was able to come on the show. Up next is our Tech Tips segment.
You have questions, they have answers. This is Tech Tips.
This is Brian O'Connor with Carboline Tech Service. When coating concrete, it is important to remove the latence layer of the concrete, as that is the weakest link in a system if applied to. Properly mixed coating will adhere to the surface, but if that surface is not sound, the surface can delaminate. If you ever see the coating delaminate and there is concrete on the backside of the coating did its job and adhered as designed. However, the surface preparation or concrete integrity is the failure.
Thank you again for listening to the show. We'll see you guys in another month.